Hi guys, we are continuing the lesson on properties of logarithms, and in this section here you're going to learn about change of base formula. Now the change of base formula was used whenever your calculator could not put in the base of a logarithm, so you could convert it to a base 10, or you could use a base that they could share in common. You could rewrite the number. It's not used as much anymore because you can just directly type into your calculator using the base. You could just type in the problem and determine the solution. So I'm not really going to go into too much depth on this, but really all you have to do following this formula here, so essentially what you could do is change this logarithm to have a different base, and you would need to, whatever that base is, pick it wisely, choose it wisely. Only choose it if you can really use it to help you simplify. Otherwise, choose a common log. So you could take the log using whatever base you chose of the x value divided by log of that base that you chose of the base. So down here, I could do this two different ways. I could say, if I wanted to use a common log, I could do log of 27. Again, I'm using a common log. It's understood to have a base of 10 divided by log of 9. Again, I'm using a base of 10, so I could just type this into my calculator, this divided by this, and get my answer. So I'm going to take my calculator and do that. If I type in log, it's over by the 7 of 27 divided by log of 9. In my calculator, I get the result 1.5. That is the value of this logarithm. Now, I could change this to have the same base. I know that what's in common with a 9 and a 27 is a 3. I can write both of those numbers using a base of 3. So I could say, well, log base 3 of 27 divided by log base 3 of 9. And I know that 3 to the third power is 27, so there's a 3 up here is what this part simplifies to. And 3 squared is 9, and 3 over 2 is 1.5, which is the same answer that we got over here. Again, it's not really necessary to have to use this because your calculator will do it. If you're allowed to use a calculator, then you can just type it in. If you go to the math screen, use the math button, and you scroll all the way down. In mine, it is A, and it'll say log base, and we would be able to type it in using that method. Alright, let's move on to the next slide. Seismologists use the Richter scale to express the energy or magnitude of an earthquake. The Richter magnitude of an earthquake, M, is related to the energy release in ergs, E, shown by the formula right here. This is what I'm interested in. Here's the formula that I'm going to be using. Then it says, in 1964, an earthquake centered in Prince William Sound, Alaska, registered a magnitude of 9.2 on the Richter scale. Find the energy released by the earthquake. Well, 9.2 was the magnitude, so 9.2 is the M value. You're going to need your calculator here. We're going to apply a lot of properties. The first thing we want to do is take 9.2 and put it in for M and rewrite our problem. 9.2 equals 2 over 3 log, we don't know what E is, E over 10 to the 11.8 power. That's an 8 here. Alright, so the first thing we do, you need to think about each part here and what they represent. 9.2 is a number. 2 over 3 is being multiplied by all of this. Remember, logs of some value, that right there represents a number. All of this here represents a number. So it's 2/3 times this log. So what I'm going to do is I want to get rid of 2/3 here by multiplying it by 3 over 2 and get it to the other side. Multiply by 3 over 2. So in my calculator, I need to say 3 divided by 2 and multiply that by 9.2. And I got 13.8. So now I have 13.8 equals log of e over 10 to the 11.8 power. All right, now remember, this is a base of 10 here because it's a common log. Now we're going to use another property. That one was just solving equations. You just got rid of what was on one side. We're trying to get everything away from e. But because e right now is part of this entire log, I can't just say, all right, multiply here because I've got log glued to it. So I need to split these up. And because it's division here, I think back to those properties and I say, ooh, I can separate those. If division, I can separate them using subtraction. So I'm going to say log of e minus log of 10 to the 11.8 power. That equals 13.8. Okay, now let's look for another property that we can use. Okay, understanding that these are common logs, common log here. Well, the common log, if I look at this here, it's log, common log says base 10, but we don't see it because it's just understood, of 10 to the 11.8 power. Well, we talked about a property with this one. If the base is the same as this base, then they can just cancel out and I'll have 11.8. So here I have log e minus 11.8, and of course 13.8 on this side. At this point, I think that you'll see that you can just move the 11.8 over, plus 11.8, plus 11.8. I'm going to extend the page a little bit. Okay, we need to take 13.8 and 11.8 and add that together. We get 25.6 equals log of e. Now we need to write this in terms of e. Okay, so let's think. We know how to convert this from logarithmic form to exponential form. The base is understood to be 10. This is your exponent. And it equals that value. So, the energy that was released by this earthquake is 10 to the 25.6 power. That's all I need for you to do. That's a really large number. It's 10 times 10 times 10 times 10 times 10, 25.6 times. So all I need you to do is up to that point. All right, we're going to practice a couple of those in class too with all of the properties. So if you have some questions, please let me know. Okay, goodbye.